So that is the question from CSR NET 2022 September 2022. Okay, there is a question from complex analysis. So yeah, here's the question. Here's the question. So if f is entire function such that f square z plus f prime square z equal to 1, consider the following set. X is like f prime z equal to 0. Those z such that f prime z equal to 0, and y is like those z such that f double prime z plus fz equal to 0. Okay. So these are the options. That is a question from unit 2. So that is a MSQ question. Uh, okay. So first option is either x or y has a limit point. Second option is if y has a limit point, then f prime is constant. Third option is if x has a limit point, then f is constant. Fourth option is f of z belongs to one the set 1 comma minus 1 for all z. It means the range of f is a subset of 1 comma minus 1. Okay, so let's see some observations first. So my observations are like, what is the obvious function for this thing? We know that, right? That is sin z or cos z, right? These are observations. So using that, you can see that option 4 will go away. I mean, that is false. Then so if I take like, let's say, sin z, then if I compute what is y, that will be like okay. So what is double prime of sin z? That will be minus sin z, है ना? And so f double prime, that is f double prime, then f prime, that is sin z, that is always 0, right? So y will be just c. So obviously y has limit point, but a prime is not constant, right? So 2 and 4 gone for using that simple observation. Okay, but we will do the question step by step using definitions and in a simpler way. I mean, if someone don't want to construct such example, I mean, how such example come? I mean, yeah. Okay, let's do that. So we have this, right? F of fz square plus a prime z square equal to 1. Uh, Actually, 3 will be little difficult. I mean, not that difficult. For that, we need a theorem that I will state, and I will give the reference also. That's called Zero's theorem or identity theorem. Okay, I'll do it. Okay, so we have that. Now, if we do differentiation, I mean, why they choose y like that and x like that? So there is a catch actually. Uh, so if we do differentiation, then we get that 2fz a prime z plus 2 f prime z f double prime z. Now, if we do some manipulations, we get that thing. Okay. Now, from here we can see why they have chosen xy like that. Okay, right. So that is the thing. Okay. Now, for one, I mean, okay. So one observation: if f is enter, then f prime and f double prime both are enter. Okay. Now x is that thing, and y is that thing. Okay. Both are complex numbers, right? Both are complex numbers, and that is 0 for all z in C, and that is trivially 0 everywhere. So x and y are complement. I mean, these two actually. I mean, if you take union of x y, these two will give C, right? है ना? Because let's say there is a point z such that who is double to x, z in C. There is z in C which does not belong to x and does not belong to y, right? It means that is also non-zero, that is also non-zero. Then obviously the whole thing will be non-zero. The product will be non-zero because these two are complex numbers. So the union should be whole C. Now, if the union is whole C, obviously one of them should be uncountable because two countable set union of two countable set cannot be C because C is uncountable, right? So obviously one of them is uncountable, and we know uncountable subset of C has limit point. So the first option is true. Either X or Y has a limit point. So A is true, right? Now, now we will do 3 because 2 and 4 was easy by that example sign J. Okay. So for 3, we are going to state a theorem that's called Gauss theorem. The reference is Conway function analysis. Sorry, Conway complex analysis. Okay, complex analysis by Conway. You can just find the book. The page number is 78. Okay. Uh, the theorem says. So I'll state a general version of the theorem. The theorem says if G is a connected open set, and we must need connected. Okay, and G from G to C be an analytic function, then the following are equivalent. First option is G is 0. The second option is there is a point in G such that G power n a is 0 for each n greater equal to 0. I mean that come from power series expansion, something like that. Okay, that you can see the proof, but that is important actually. B here we will use only C and A are equivalent. Here we will use C and A. Okay, but B is also very important sometimes. Okay, C says this zero set of G. I mean this those J's, so the Gz equals 0 has a limit point in G. In G is very much important. Okay, if I mean it might happen that uh, it might happen that I mean let's say you have unit disk, you Z is let's say the disk. Okay, it might happen that the zeros are like that. I mean it is like that going to boundary. I mean the zeros are going to boundary like that. Uh, in that case, I mean that kind of function are available actually. You can take sine 1 by z. You can take f of z is sine by 1 by z and take your g as the centered at disk centered at say 1. Okay, then you can see if we put z equal to 1 by n pi, so 0 is not there. Okay, or also g you can take c minus 0, है ना? 0 c z equal to 1 pi, this are this are 0, this belongs to the 0 set, right? These are the 0 set actually. What is the limit point of that set? That is 0, right? But 0 is not in G, but f is non-zero and analytic in G, right? So that is a counterexample. Uh, that is not a counterexample actually. I mean, I was writing that thinking about something else, so just forgot it. Okay. Here we have G is equal to C. I mean, for our question, we have the full domain, right? Entire function, na? So we have no problem here. We don't have to think about connectedness and all that thing. So it is connected. Okay. So for three, what the option says, it says if x has a limit point, then f is constant. So x is what? A prime, z is 0. Here I'll take z as a prime. So basically x will be the set of 0 of G. Okay. The 0 set of G. G is a prime here. Since x has limit point, then G will be what? 0, right? It is trivially 0. Okay, on whole C, that is A prime is 0. A prime 0 means F is constant. Yeah, so 3 is true. Okay, F is constant. Now, this 2 and 4, I gave the example earlier, but using the zeros theorem, we can also do that. How? So, for 2, take G equal to F plus F double prime. That is analytic on C. And so what 2 says? 2 says if y has a limit point, then F prime is constant. Okay, so y. Y is what? Y, if we write in terms of G, that will be 0 set of G basically. And if y has limit point, then G is 0, right? Using zeros theorem. C0 means F double prime plus F0, and F is differentiable, so we can use ODE theory, right? Ordinary differential equation theory, and we get that equation. And what are the solution? That is the solution, right? Where C1 and C2 are arbitrary constant, so we can take C1 0, C2 1, C2 0, C1 1, or some constants also you can take. So from here also we get that example, right? Here F prime is not constant, thus 2 is not true, right? Also 4 is also not true, that is immediate. Done. So 2, so 3 is true only, and 3 and 1 is true, and 2 and 4 are false. Okay. Yeah, it was asked to find the true statements. Okay, so I got the that part of question. So it was asked to prove, I mean, to find the true statements. Okay. Okay.